Okay, let me see who I've got here. Okay, Brian, glad to see you. Sarah, you as well. I know we'll have some others join us. And I'm going to go ahead and get started just a bit early so that we can get you out a little bit early so you don't have to tramp through the rain too much. I hope most of you have your classes over in Bailey. And if not, I hope the trek over was a good one. It never ceases to amaze me when I see people on a day like today walking to class holding their books and their computer with no jacket. I've seen people out there in shorts and flip-flops. I don't get it, but who knows? Well, anyway, I'm going to go ahead and get us rolling here. And of course, we're in week 5. And I want to take just a few minutes to let us kind of get our bearings and see what's going on. This is Virtual Wednesday, of course. And let's take a look at what we've got going on in terms of assignments. And as you know, you've got the county. We talked about the DEA, Data Envelopment Analysis Technique, quite a bit. In fact, I spent the entire class period on it, and I think I've covered it sufficiently. The text covers it. I give you the passage of the text, and you'll want to upload the file itself, and it's over there in the Anderson student files, and you'll see that in the files section. So it's there for you to upload. Then we have a couple of other cases, Foster, and this, if I'm not mistaken, the Foster case is from chapter 6. And I'm over here in the text, and let me see, I was talking about the Foster case, 259 to 265. There's that passage as it starts on Foster and using revenue management. Now, the other case that we looked at there, in addition to county, was Gorman. And the Gorman case, and I'll just do a quick search here through the text so you can see it. And that starts over on, they start over on page 668. Now, I've got Gorman 279 to 283. You would certainly, and that's a big change from the chapter 6 files, Foster Gorman. So I'm going to go back to chapter 6. That's where I messed the things up. I didn't input the query correctly for the search. There we go. And this involves a distribution and a network problem. Now, I believe that since we're at the point in the course, and let me see who else is here. Jared, Brian, Sarah, thank you so much. Glad to see you here. Colton, you as well. I'm sure we'll have others join us as we move along. Now, what we've looked at here are a set of cases. Well, let me say this first of all. County, which is that data envelopment analysis case, is a different critter from the ones that we've seen, for example, like Leisure and some of the other network or logistics kinds of cases that we're going to see. And I think that we covered the Leisure case fairly well. And then county's a little bit of a departure from that as we take a look at how creating a benchmark, that's the composite, and using it to compare operating units. And I talked about some of the systems issues that are involved and practical issues, that type of thing. Now, if you go into the textbook, I believe the county is over there in chapter 5. And let me verify that for you in the chapter 5 files. We'll just do this real quick. And all you have to do is take a look at, I didn't have you manipulate any variables there, okay? Let's see if we've got, there we go, in the advanced linear programming. It's over in chapter 4, and they give you that discussion. Now, the result set for county, all right, and as we walk through that, the textbook gives you the, if I'm not mistaken, the lingo output. Now let me make certain that everybody at this point understands what they're seeing in the text. When you see the lingo, and there you can see me, one of my shots. When you work with lingo, you're working with kind of a baby optimizer that the publisher has created over at a companion website, and the book book assumes that you'll put the data in and you'll run it through lingo. Lingo is platform agnostic, so it doesn't care if you're using a Mac or a Windows-based machine. However, it was another $200 to $250 per book to the package. So I said, okay, I'm going to save you the money. And 95% of the places you work, if you do any optimization, will probably work with Excel, or you may work with one of the various proprietary applications that are out there. Not to fear if it's not Excel, you know enough about the process that the software or the application really will not seem that foreign to you. And the truth is, if you start talking large scale networks, the managers or the owners or the key people in a particular function who have a dashboard that's tied into some type of optimization data you're gonna do some clicks, you're gonna look at some data, you'll have a benchmark, and you'll get a sense of what's going on. Again, it's just going to depend upon the industry you're in, and there are all types of, but essentially, Excel is, again, I use the analogy. If I teach you how to drive, okay, using a Ford Focus, then it doesn't really matter from there on out what you drive. You know how to drive. Now, if you decide to become a NASCAR driver, you'll go through some training. Or if you decide to drive a Lamborghini, proceed at your risk if you can afford it. But the whole idea is that we are preparing you to be comfortable with the kind of layout and to understand what that tool is supposed to do for you. We have a board of executives in the college. These are former students, and they'll meet with the dean, and it's almost every time they meet, they'll say, why don't you teach this particular application or that particular application? Now, what I do is to provide all of you in each of these courses with what is at best either the state of the art or the biggest market share, like SaaS, or Oracle, or SAP, but beyond that, I would do nothing but teach one course of how to use this after the other. And if you really want to kind of get a feeling for that, Oracle, which is a database data warehousing program, and also provides you a dashboard from that. Oracle has a guide to their retail product. This is for retailers. That's close to 250 pages long. So when you buy the Oracle program, you walk through it. So I wanted to say that so you understand, and you keep your eyes and ears open, saying, okay, I'm getting some general kinds of principles here in terms of how it works. So I won't belabor that any, but again, you'll want to go into the student files. You'll want to upload. You'll want to take a look at counting, and then you'll want to look at Foster and at Gorman. Now I want to start with Foster, okay, and we'll just take a look at what we're going to do. Now I also want to mention that the output, things like a sensitivity analysis, the solution, those products or those analytic reports that you get from Excel are highly variable, And we've talked about sensitivity analysis and what that means. We've looked at limits reports and talked about what that means. So we have a good sense of what we're talking about. And I'm glad to see, I think, Noah here, Jake, John, Long. Good to see all of you. And let me see who else I've got on here. Michael, Patty, Robert. Good to see you. Azrid and Jerry, and we got Logan. Thank you so much. And it's a rainy day, and there's a lot to do. Now, let's look first of all and see if we can take it in the order I've got. We've got Foster. So let's take a look at the Foster case real quickly. And as I had mentioned, we key in on the pages 259 to 265. And here we go. This is a company. They make generators, and they have a transportation problem. Now, there are two types of transportation problems, okay? Really three. Let me start with the first. The first one is inside of an operation, like a fast food outlet has a transportation problem because they have to move things and move people, interact with customers. They have all of these places. They have bins and places where they fix things. So you have the network effect that's created by having to greet a customer, go to the window and get a drive-through, get the fries, etc., is what we would call an internal transportation problem. When you go into a situation where, for example, you're into a supply chain where you're on the receiving end of the supply chain, others people are delivering stuff to you, you now have a different kind of transportation problem. It's an inbound problem. And you say, why is that a problem? Well, if your vendors don't get stuff to you on time, you can't sell it, all right? Or if it's perishable and they're late in the delivery, you may have some waste. Now, if you have a good business partner, they may send you some stuff that it goes bad, and they'll say, well, we'll make good on it. Unfortunately, though, if your clientele comes up to the window and says, I'd like a vanilla shake, and you say, we're sorry, our shake machine is not working, or whatever, you probably will lose that person. They probably won't come back. They'll do a substitution. Brand loyalty and things like fast foods is almost non-existent. You have a few fanatic people like myself. All I can say is I'm a Carl's Jr. person, and I will be to the day I die. I like Jack as well, but that's about it. Okay, but I'm not the norm. The standard, the norm is people will go different places. And just so that you kind of see that, Dunkin' Donuts has now decided they're going through a rebranding process to simply call themselves Dunkin'. And the reason is they have some stores, and I've been one of them. They have one over here in Oklahoma City where they don't just sell donuts, they sell, oh goodness, they're selling sandwiches, and they partner up with it's not Brahms, it's the 31 flavors. I can't remember what brand that is, but they're selling ice cream with a partner. They sell salads. So they're moving themselves out into an expanding market. All of them are. So they're virtually 24-hour day operations. Well, all that being said, let's take a look here, okay, at this problem that we have. And the transportation problem is really, it's a distributional problem. We see they've got some origin points, okay? And then we get an idea of the 3-month production capacity per plant. Now, I want to add something here that the authors don't speak about because they assume you've had a production course, and I have to assume that too because we have one on the books. So if you're a management major, you should have taken production. If you haven't, production and project management, I hope you have. When they talk about capacity, what the authors probably refer to is not the theoretical capacity. They refer to the real capacity, and there's a big difference. Theoretically, I could make so many units of whatever, and from all practical terms, I've got to take into account 2 or 3 people are sick, and so it slows the line. I get some stuff delivered to me late, or even worse, I get some defective components delivered to me, and that shuts the line down. Or I have bad weather, or any one of a number of things, or I have an influenza break. So industry has developed some techniques, and this is not this course does not cover it. It's way beyond this, to say, given the typical type of production line or distribution operation, whatever, what's the realistic capacity? So I'm assuming here the authors of the data are based on on real production units data. And again, this is one of these things you'll hear me encourage you and talk about, to think about is, are these data good? Okay. Are they accurate? What are they based on? And again, that would be an entire course. And so we're working with some assumed data that we assume the organization is doing a good job. Now, here we come to see at the top of page 260, all right? And I'm sorry to be so didactic, but unless you see some of the background here, when you open up the Excel file with the optimization in there, it's not going to make any difference to you, or you really won't see it. You almost have to see the narrative. And so this book is quite good in the sense of giving us some bare bones narratives about these types of problems. Here's their transportation problem. Now they have 4 destinations, okay? So let's go back and pop back for just a minute. We have points of origin, and then we have destinations. This is very similar to the issues that we have when we looked at the airline. And again, we have these destinations, and they have a 3-month demand forecast per destination. So now we have the ingredients for a typical transportation, or i.e. network problem. Now, let's take a moment, and I want to just kind of refresh for us, or review for us if we're not aware of when we talk about a network. Okay, here's what we have. We have a beginning and an end. We have nodes, okay, and those nodes are places where we end up along the way from point A to point C, okay? And then we also have what I call paths. This is illustrated right in here in figure 6.1, right? Network analysis, if you go to work for, if you go and, let's say, you went through our program here, and the University of Oklahoma, for example, has a fantastic logistics program. Some places have an MBA with logistics as a specialty, but you do nothing but work with those logistical problems. And I will say it again, there are really 2 things that enable us to have a global economy. One of them is standardized containerization of product that we ship internationally. And the second is a good understanding of how networks operate and a variety of network operators to get stuff from point A to point B. I've thought at times I'd offer a course on logistics here, but I don't think I may want to take it. But when you get out there and you start to understand, as a consumer, you've probably experienced it. You just didn't walk back when the stuff didn't get there, or it was damaged, or whatever. Enough of that. Now, as you can see, we see the origin nodes, the plants, and we see the destination nodes. Okay? And then we can see the transportation costs per unit. Again, we're assuming that we're seeing figures that there's probably been a tremendous amount of work that's gone on with that, and negotiations. All right. And then we see how many units are sent to each distribution center. So we have a plant, okay, and we have a destination node, which is a distribution center. This is pretty typical. Okay, now if your distribution center stops at Boston and you have multiple, there's a third set of nodes right here. Okay, that's what we call the last mile problem. It's one thing for me to take a whole bunch of stuff and load it and send it to Boston, but when it arrives in Boston and I've got 250 places it needs to go, that's when the fun begins. And that's why people like FedEx and UPS dominate the market. There is no one else, and all of you I know have studied to some extent Porter's competitive analysis, the way that it's business strategy, and we talk about the relative power of suppliers and the ability for substitute goods, and a Porter strategy analysis fits perfectly here. It is we might see a third distribution company arise, but they're going to be really they're going to be in for the fight of their lives, because UPS and FedEx are so highly capitalized, not only from a standpoint of equipment, but in terms of their intellectual property, that's such a hurdle to overcome. It would be exceptionally difficult for anybody else. Now, there are some sub players that do delivery, and then below them a tier of local players who come into play because maybe they handle specialized things. For example, if you're sending out, you've probably seen them out on the highway. People are components of these giant wind machines for wind farms. They're incredibly huge. And I remember when we lived out, we were out in Arizona, my wife and I, and we'd drive over to see some relatives over in Los Angeles. I was there as you just start to get out inside of, as you start to get to Palm Springs in that area, there are some giant wind farms. And pictures and movies or videos do it no justice. You realize these are huge, huge things. We have some wind farms here as well. I don't think UPS or FedEx handle that stuff. There are specialized carriers, or for people who carry oil equipment for oil companies and certainly emergency management and all that type of thing. Okay? But I want to give you some of the background and meat that's with these two cases, especially with this Foster case, because we're looking at a pretty classic issue. So at this point, we've got the distribution centers and their needs and the plants. And so as you follow those arrows, you can see who's sending stuff to whom. Okay? And let's take Cleveland, for example, which is origin node number 1. And Cleveland produces and sends stuff to Boston. They send stuff to Chicago, and they send stuff, it looks like, I think that's Lexington, Kentucky. Okay? The Lexington, Kentucky, and St. Louis. And you say, okay, why would that happen? Well, it may be that history of the company, maybe somebody got a deal, who knows? But we're seeing the results of probably a lot of time and effort and negotiating and company history, maybe some industry standards, who knows? And as we come down here, we see the supplies and the demands for each of these. And we can see then origin node 2 is Bedford. Then we see York and who they ship to. So we have a fairly complex network. And you'll notice this is not necessarily linear. The great challenge of this is that the distribution or the data points are not particularly linear. You've got layers of stuff coming in outbound. Now, the good news is this is all outbound. The bad news for these destinations is I'm getting stuff from two or three different places, and I got to be ready to accept it, receive it, and store it. And again, I'm going to put my pitch in to all of you who, if you're a marketing major, for example, I believe personally one of the best moves you could make would be to do an internship with a logistics firm, and to maybe start to look at that as a place to work. Because if you can't get it to the customer, it's not a sale. Okay? And I'm going to say that over and over. People, obviously, a lot of people know IT and all that is my thing, and I've worked in e-com. I can tell you for a fact, you can fill that basket at Amazon all you want, but if you can't get the stuff to the customer on time and in good condition, you're going to lose a sale. And unfortunately, you're going to end up receiving the stuff back, so you lose the profit, plus you have another transportation cost on top of it. The worst of all items that's sold out there in e-commerce are shoes. People tend to choose 2 or 3 different types of shoes, and they think, well, let's see which one fits. Okay, and then if you are stupid enough to have a return policy for free, and they order 4 or 5 of the pairs of shoes, guess who's eating that cost? You are. And if you're nice enough to provide them with a box to send it back and everything, so they can just take the box down to the FedEx or UPS store and say, here, send it back. I don't know. I'd say you're probably not playing with a full deck. Okay? Now, let's go on down and take a look at this, and we'll pop over. And here we see the cost per unit. And so we've got that laid out. Now notice how we've looked at 3 tables that put in tabular form what we're seeing here in this figure. And again, I point that out just so that you understand. Data presentation, data visualization is exceptionally important. And we all tend to think in terms of tables. I've got a table here, okay? The origin points and the destinations. And then I've got the transportation cost per shipment. Now look here, so you got some other people, okay. So everybody good. Glad to see all of you here. Now, we begin to start to build the mathematical model. Now, we already have a graphic model, if you will, figure 1, that shows us all the movements of goods, who's the origin node, what's the receptor, i.e. the distribution nodes, and we know the transportation costs, and we see the direction, okay? And if you say, this looks suspiciously like a bunch of tables that I have seen all connected together in data admin when I looked at the relationship tool in Access, and I would say, precisely. One of the fascinating things is that inside of every organization, things operate along a flow. Information, physical material goods, and money, or some type of token of money. They all flow through. And when you start to understand that dynamic, then you start to really see how dynamic business is and how fragile it can become if you're not careful. Now, we'll move along here, and we're starting to build our mathematical our model. And so here at the bottom of page 261, they give us the constraint for Cleveland. And they continue on where we build in the constraints for supply and for demand. And then we see in its full beauty, we see the objective function, and that's the minimization problem, and you can see the subscripts there. And that's one to one, and that's origin node to destination node, and subject to, and then we have the constraints. And notice we have some mixtures here. The greater, now we have two kinds of constraints here, an equal to or lesser than, and then we have just straight up equals. That tells us I've got what I would call a semi-complex kind of problem or optimization problem. Where it really gets crazy is when you've got greater than and equal to's mixed in here. Then you really have something that solver can put its teeth into and go to work. Well, here we have the whole thing laid out, and then we see the problem variations, and you can notice what we're talking about. And again, we're trying to minimize, okay, our costs. And they walk through some of these variations or the things that go into the route. For example, let's take a look at number 4, unacceptable routes. Construction occurs. Now, right now, in the Carolinas and much of that area, it's a nightmare because of the flooding. Things are washed out. There's still stuff underwater. God bless those people. Pray for them. If you've got a little spare change, send it to them. They are really, really, really having a rough time. And it's because so much of the infrastructure is still covered by water. And when you're cut off, you're cut off. I followed with a lot of interest what happened in Puerto Rico and what continues to go on in Puerto Rico. And those folks have gone through a meat grinder. And again, you can only imagine the nightmare that's created when you have a way to get to a place. When I drive to school each day, okay, I come in off of MacArthur. I'm coming in off of 77 out of Oklahoma City. I take 40 to 77 down, okay? And there's that bridge that goes under where the airplanes land. If that bridge gets flooded, I suddenly have to route myself back to come all the way to the north and come down via Kickapoo. If something happens with Kickapoo, then my choice becomes to go down to 77 to try to swing back in. But it wouldn't take much in terms of some really bad weather, flooding and bad weather and construction to pretty much isolate the campus. So you have to take those kinds of things into account. And again, total supply not equal to demand, maximization of the objective function, route capacities or route minimums, and much of that you're subject to vendors and folks who are carrying stuff. They're there to make money too, and if they can develop a milk run, they're going to do it. If you are someone who they have enormous difficulties taking care of, you better be prepared to fork over an additional money for their services, or be prepared to find somebody else or build it yourself so you can get it to the customer. Well, we get the optimal solution, and of course this is from the web, this is from Lingo, and we can see each of the optimal objective value, and it gives us that, and we see reduced costs, and so we get a sense of value and where we might be able to reduce some costs. And here's the optimal solution, how much we'll send. And we start with Cleveland. and we move from there. And you can see the total cost and the cost per unit. And that's the minimization problem. All right. Now, again, they walk us through some of those qualifiers that we had. And here's the solution. And as you see, we've eliminated some routes. We've increased the volume on some other routes, and we're working our way through that process. Now, and they give us some explanations that, and then they talk about the general linear programming model as it's applied, a template, if you will. And that would be pretty much it. Now, I want to take a moment and let's pop back over into, and I want to look at Gorman, okay? And we'll go back into the text. Now, look, I haven't opened the files up today because they're over there in the Anderson Chapter 5 files. All you've got to do is go find the Excel files. And based on what I've shown you here, you can take a look, open Solver, look at the reports and see them for yourselves, all right? And of course, you need to upload those for the workshop credit. And I haven't asked you to manipulate any of the variables, so just upload the file. That's my way to know that you were here, you were attentive, you read the book, you looked at things, and you uploaded. And I trust you that you do that. See, one of the things about my courses that makes it very difficult, deceptively difficult, is I challenge you to, and you'll find out for your own self, are you really motivated to say, okay, I'm going to take the text and I'll upload that file, but I'll take a look and see how that flows out, okay? I'm going to turn you loose with projects to do where I don't have class. I do that every week. We have the lab time. And what it really boils down to is this. I'm going to give you that opportunity to see for yourself if your time management skills are good, if your self-discipline is good, if you're really committed to learning your craft, and that is being a business leader, and you'll learn for yourself. And I give you that opportunity to find that out. Better you find out now that, hey, my time management skills are really kind of bad, than you find out when you go to work. And so there are times when I think, because I'm kind of an affable person and I joke a lot and I make a lot of self-deprecating comments and jokes about myself and I'm kind of easygoing, that I may somewhat give you an idea that I don't find this intensely important for you to know. I do. And it has to be inside of you to say, I want to learn this and I want to know this. I can tell you right now, I don't care what business you're in, no matter how big or small you are, if you don't have a grasp of your company's analytics and you don't have a grasp of supply chain, you won't be around. Somebody will gobble you up and buy you out, or they'll just simply destroy you and take your market, because everything has come down to that. In the old days, when branding could really keep and hold people, it doesn't work like that anymore. In the old days, when you could count on long, continuous production lines, it doesn't work like that anymore. It's analytics, it's supply chain, and I cannot emphasize that to you enough. I would be fooling you and tricking you if I told you anything else but that. Now, in some industries, it's taking longer, okay? But they'll get there. One of them is the industry in which I work, higher education. I can tell you right now there are schools that have 50, 60, 80,000 students. And they operate on a scale that's unimaginable. And they've done it, and they've created what they call a blue water strategy, so they can reach into almost anywhere in the country or around the world and offer educational programming that is accredited by the same folks that accredit our business school and accredited by the same regional accreditor that accredits us. And those folks are all about analytics, and they understand supply chain. They understand that they've got to have their network up and running. They understand students want to get their books. And so it's been interesting as I've watched this unfold, and I've seen industry after industry just virtually getting transformed. The science of a lot of these industries, okay, is something that's to behold. I can tell you, for example, right now, that there are people working on a canvas that will have you come in, give you kind of an intro course, figure out how will you best learn, and then begin to tailor it all to your needs. And that's the holy grail for these learning management systems, okay? So again, we're learning some pretty important stuff here, and I will not underemphasize that whatsoever. Now, let's go back over there to the text, and they give us an example there of Union Pacific, and here we come into the transshipment problem. Okay, this is a firm called Ryan Electrics. We've looked at Foster, and now let's go to Gorman. So I'll do a search for Gorman. And this is a construction company, and here they're dealing with what we call a northwest corner problem, the shortest route. I've got to find the shortest route. Here's an example. Okay, and this is something I learned when I was an executive director. I told you about this of a gated community that's out west of St. Louis that is a self-contained city, but it also has all the components of a resort. So I was running I was like a park superintendent and at the same time like a city manager. And I had a really good practical experience with shortest route problem. That community has three lakes that have a dam, and the state of Missouri certifies those dams. They have people who come out and do soil testing. They look at they would do some imaging to make sure the dams don't fail. All right, you can't have that happen. Because we had neighbors who lived, I think that we had some neighbors down the way that were maybe 10 or 15 houses. If the dam had broke, it'd destroy them, and they'd sue us for more money. We could pay them 1,000 lifetimes. So we had to get those dams certified. Well, my first year, as fate would have it, one of the dams had a problem. Well, you don't just drain the thing and then rebuild it. You don't do that. You do it in process. So what we had to do was grout the dam. That is, we had to find where there was a vacuum, where there were areas that cracks were starting and we were going to get water seeping in, and we had to inject it with a concrete mix that's specialized for that type of situation. That's watertight, that holds the material. And I learned about the shortest route problem because that stuff, because it's basically concrete, sets pretty quickly. That's why, if you fall, and there are probably some of your mom and dad are in the construction business or you work construction, so you get what I'm saying. So when you have concrete and it's headed to a destination, you see that roller is keeping that concrete fresh and keeping it from setting. And you want to pour it and you want to get it into the mold, and so that things are going. And so as we had we had to figure out how many trucks of this stuff would we have to have, and we had to close off roads, all this thing. But I learned what's the shortest route, because we were given only a certain amount of time. Now we dealt with a concrete company that was all the way down in St. Louis. They had the best materials, and they were the most experienced at doing this. They'd worked with the Army Corps of Engineers, the state of Missouri, and they were our vendor. So on the day that we were going to grout the dam, they had, I don't know, we had like 15 or 16 cement trucks ready to go. And this is all, and people are as nervous as they could be. This has to happen, because if the stuff gets there and it won't inject, then you got a problem. And if you don't inject it all at once, boom, and it starts to seal, you can create more fissures and we were dealing with earthen dams. To make a long story short, worked out, got things done, no disasters. So we had a shortest route problem. This company has a shortest route problem too that it's working with, okay? And it's what they call a transshipment problem. And you'll notice, let's pretend this is that gated community I worked for at Lake Sherwood, and let's pretend that this is a operation there in St. Louis, and not DeLisi. DeLisi's big in Oklahoma. This is another firm. They were a cement company, but then they began to build specialized cement, particularly for stuff like, I'm sure they probably now supply people who do fracking, because their specialization was injecting stuff in concrete injection, not just setting it in a frame. And so you could see the road distance, and you have to start to work out what's the quickest way to get here. And we have a new term that they've introduced for us here in terms of network analysis, and it's what's called the arc. And here's the arc. So we have a node, an origin node, a destination node, and an arc. Okay? And so we see the road distances in miles. And of course, you have to figure that out in time. All right? And when we did the grouting of the dam there, we did it at 3 o'clock in the morning, so that there was virtually no traffic, and they could hit I-70 and come out west of where we were, get off at the exit, and go down. And the community that was down in Warren County, and they could get down there through these country roads with no issues. And they came. It's the same story here, trying to look at the road distance in miles and work all of that out. Again, we see this transshipment problem is more of an internal issue, but we've got the government, their office, okay, and they want to know the shortest routes to each of these nodes. And again, here we understand first of all, we understand we're dealing with the minimization problem. And here's the objective function, and there's the notation. For example, on that first one, it's origin node 1 to destination 2. And you can just walk through that iteration. And then we have a constraint for node 1. Okay. Then we get the flow ins and the flow outs and the flow ins. Sending stuff per node, and then what flows in. And want each of them, okay, to equal 0. These are the constraints. And the flow out minus the flow in has to be 0. Why? We can't overload any node. They're only capable of receiving and handling a set amount of stuff. Okay? Think about this diagram here. The next time you go to a fast food place, think about how, and if you can get a peek, take a look and see how much storage space they have. It's unbelievable. Okay? And it's those people, you know, the good Lord giving us the brains to figure this stuff out. So you and I can sit down and chomp through our favorite burger or fries. He says this is a picture of how much God loves us. He knows we like burgers and fries, so I'm going to give him a brain to figure out this stuff. Now, I know this sounds a little silly to you, but if you look at the book of James, what does James say? All good things come from God. And he loves us enough that if we want to have a burger, we can have a burger. So if you're worried about whether he wants to send you to hell or not, if you've made a commitment to him, he's not going to renege on that. He never changes. That's why he made this incredible world we live in, and why we ought to be good stewards. And this is a piece also I'm going to put in a 2 cents thing. When we work through these logistic problems and we reduce our carbon footprint, we're being good stewards of the world God's given us. So there's far more here at stake than just us making some money. And then we see the Gorman shortest route. Whoa, there's the minimization. There's the objective function, first line. And then we see the constraints. Okay. And for the origin node, the transshipment nodes, and the destination nodes. And here's the optimal solution. And they show us some opportunities where we may have some reduced cost. Okay? This again is from the lingo. When you open up the Gorman Excel file that's over there in the Anderson student files and you upload it, take a look at it, and you can see, and you'll see these, and it will have some meaning for you to do that. And it will make some meaning for you. And let me say this. I know some of you are there going, you are really stoked about this, aren't you? And I am. For a very simple reason. If we're good stewards of the earth that's been given to us, if we reduce carbon footprints, if we can get stuff to people on time, you see, business people have it in their capacity to act out and demonstrate God's love in the world in little ways. But I really believe that there are going to be many people who when they stand before the Lord to get their crown, and I believe there are a lot of janitors, waitresses, delivery people who are going to get some tremendously huge crowns because they demonstrated God's love by being good people, good employees, and really caring about the customer and caring also about the world in which we live. This is how we can act out the gospel. And this is how we get people's attention. People, we can preach at them all day long. They'll probably tune us out. But, and here's an interesting thing. Chick-fil-A is closed on Sundays, but they remain highly profitable. How do they do it? Well, it's because they have a superior way of running their business, their franchises. They've figured out so much. They give you fantastic service, and then they can shut down on Sunday, not to be big show-offs, but to say to the world, that silent building says, hey, it's the Sabbath. It's the day of rest. It's a day for us to relax with family and friends. And that's a great witness. The people who also are open on Sundays are a great witness to people. So again, we can do the Lord's work doing these kinds of things. Well, I'm at 11:50, and we could see the general linear programming model they had. This is the template, the recipe, if you will. And we get those results. And then we'll see some maximal flow problems as well. Well, folks, listen, I do appreciate all of you who've been here today. And hopefully, I have added some to the textbook in terms of its discussion, and hopefully maybe giving you some insights I've gained from having been out there and having to have overseen these kinds of things or deal with them throughout the time I've been out working in my career. So I'm going to stop for a moment and give you the standard. Does anybody have a question I could try to help you with? Anybody? I'm waiting. Anyone? Okay, if you don't, God bless you. Be safe. Yes. I think somebody had a question. Anybody? All righty. If you do, you can always shoot me an email and I can try to answer it for you. And again, don't forget what we've got going on. I'll close this off. You need to upload county, which is over there in the Anderson files, Foster, and Gorman. I have the Foster key and the Gorman key, and if you want to, you can open them up, take a look at them, and then load them. That's why I've got them there. The county, you can dig out and see for yourself. Before I go, I have some nice resources for you that go beyond the text and go beyond the lecture today, where you can look and learn about networks and logistics models and all kinds of things like humanitarian logistics.
Dr. Herman?
Uh-huh.
Are you going to
Yes.
publish that Foster and Gorman key? It doesn't look like it's published.
Yeah, those are published and they're there, and you can.
I don't think they're published.
Oh, okay. Let's do this. Let me do that right now. Thank you, Patty. I appreciate it very much. There we go. Now, can everybody see Foster? And can you see Gorman? Are they there? And I just published them, so you should be able to see them. Are they there? Do you see them?
Just a second. I'm looking for them. Just a second.
Yeah. You may need to refresh your page, and they're going to be down there in the module. So I don't think I.
Yes, I see them. Thank you.
Okay. Yeah, no problem. No problem. And of course, county is there in the files. Anybody else? Thanks for pointing that out. Okay, folks, God bless you. Stay safe out there, and I will see you on Monday.